All right, let's dive into this explainer and build ourselves a well-oiled SAP Datasphere machine. If you're working with SAP Datasphere, you already know it's an incredibly powerful platform. But as with anything, power requires precision. Today, we're going to act as SAP Datasphere architects. We'll look at the foundation of your compute costs, design the literal floor plan of your spaces, and tackle one of the absolute biggest logistical headaches data teams face: how to handle advanced transports, like pushing an emergency bug fix right in the middle of a complex, ongoing development cycle.
We're going to treat Datasphere exactly like an architect's blueprint. Here's our agenda for today. 1. Cost optimization foundation. 2. Architecting tenants and spaces. 3. Packaging content for lifecycle. And 4. Automating transports with ALM. Let's get right into it.
Section 1. Cost Optimization Foundation. To lay a rock-solid foundation, we first have to address the literal costs of the infrastructure we're building on.
You know, most teams just jump right into Datasphere assuming the cloud cost model is going to magically work itself out. It's a super common trap, but reality check, you have to actively manage your underlying SAP HANA Cloud Database compute. Datasphere's costs don't just appear out of thin air, they're driven directly by how much memory, compute, and disk space you are actively provisioning to your data teams.
So here's the crucial point. Your Datasphere configuration, specifically how it hands out what are called capacity units, or CUs, to different spaces, that directly dictates your overall bill. A capacity unit is simply a fixed amount of resources you assign as a quota. If you just blindly assign massive quotas to every single space without actually monitoring the usage, your costs are going to absolutely skyrocket. Now, look what happens when we check out the actual system monitor data from the HANA Cloud Database. We usually see these huge gaps between the average memory used, say around 58 gigabytes, and the maximum spikes, which might shoot up to 76 gigabytes. This historical usage data is a total goldmine because it reveals exactly where we can trim the fat and right-size our tenant. You definitely shouldn't outright shrink your tenant based on average usage alone, but rather balance it against those maximum spikes.
The absolute pro tip derived from SAP experts here is to allocate only the memory and disk each space truly needs. And then, here's the key: add a 50% headroom buffer for unexpected growth or spikes. You might be wondering, why not just over-provision everything just to be safe? Well, because while CPU can be easily scaled down later, over-provisioning memory and disk can actually require disruptive tenant recreations to fix down the line. Toss in that 50% buffer, and you optimize performance without breaking the bank.
Section 2. Architecting tenants and spaces. Okay, let's move to our floor plan and see how this builds into our overall architecture. Knowing how to structure these containers is absolutely vital for both security and lifecycle management.
Think of a space in Datasphere as a highly secured container. It holds literally all your content, your tables, views, models, flows, and it grants specific CPU, memory, and disk allocations to the users working inside it. This means you really need some forethought. You want to avoid a situation where you're forced to replicate data into multiple spaces just to manage security. And here is a massive architectural constraint you have to remember. While read access can be shared, only one space can have SAP HANA Cloud Data Lake write access, period.
And this perfectly illustrates what you can and cannot put in the moving truck when you're ready to transport your work between your dev, test, and prod tenants. You can easily package and transport local tables, views, and flows. But look closely at the bottom row. Spaces and connections cannot be transported. They literally have to be manually recreated in the target system, and their IDs must match exactly before you try to import any content into them. Since objects relate to each other by ID across your entire landscape, we strongly, heavily recommend dedicating one whole Datasphere tenant per environment. Have a dedicated dev tenant, a test tenant, and a prod tenant. Never misuse spaces for lifecycle phases within a single tenant. And as this quote highlights, never ever hard-code the environment name into your object IDs. Seriously, call your space sales, not sales dev, because when that object finally moves to production, having dev in the name is going to cause a ton of confusion.
Section 3. Packaging content for lifecycle. Now we hit a really exciting part, the logistics phase. This is where we solve one of the most common and frustrating scenarios for Datasphere architects.
Picture this scenario. Your dev team is halfway through a massive, super complex build in the dev tenant. Suddenly, boom, an urgent bug is reported in production. You've got to fix that bug in dev, test it, and ship it to prod immediately. But if you just bundle everything up and ship it from dev all at once, you're going to accidentally drag half-finished development work right into production along with your fix. Total system disaster, right? So what's the best possible option to handle both ongoing development and emergency bug fixes in parallel?
Well, the solution is all about choosing the right container. You've got two main options here: delivery packages and repository packages. Delivery packages are your standard transport mechanism. They pull from multiple spaces and auto-detect dependencies. But for a bug fix scenario, that auto-detection is going to grab all that unfinished work. Repository packages, on the other hand, act like an isolated subspace. They're locked to a single space, they use strict semantic versioning, and best of all, the modeler manually controls all dependencies.
So, for parallel development, the absolute best possible option is for the modeler to put that emergency bug fix into an isolated repository package. Because you're using strict semantic versioning, the modeler dictates the exact dependencies within this one single package. That neatly sidesteps all the ongoing, unfinished dev work happening in the rest of the space. Then, you just take this version-controlled repository package, add it as a single object into your delivery package, and transport it cleanly to production. Problem completely solved.
Section 4. Automating transports with ALM.
Finally, let's talk about how we actually take these meticulously packaged bug fixes and standard releases and automate their journey down the highway to production.
To answer a super common community question right off the bat, yes, SAP Cloud Application Lifecycle Management, or ALM, absolutely supports Datasphere transports, but it doesn't do it alone. You gotta hook it up to the Cloud Transport Management Service, often called CTMS. Once you integrate those two, you unlock some serious enterprise-grade deployment capabilities. Connecting these systems is a really logical, straightforward process. First, you configure your source and target nodes inside CTMS. Next, you set up an HTTP proxy destination using an OAuth 2 client for a secure handshake between Datasphere and CTMS. Then, you assign specific user deployment rights in the target system, which just means imports execute under a designated user's permissions. Finally, from inside the Datasphere transport app, you literally just push your delivery packages straight to the CTMS export node.
Once your packages hit CTMS, you get some massive operational advantages. Centralized management across all your landscapes? Check. Scheduling imports to happen automatically during weekend maintenance windows? You bet. You can even enable automatic imports for highly agile CI/CD pipelines. And, crucially for governance, you get a strict, centralized audit trail with detailed failure logs for every single thing moving between your dev, test, and prod environments. So, by right-sizing your capacity units to keep costs down, using the brilliant isolation of repository packages to safely juggle bug fixes and parallel development, and automating the final delivery via Cloud ALM, you aren't just deploying software. You are building a highly tuned SAP Datasphere machine that can handle literally the most complex enterprise data cycles with total ease. So take a hard look at your own architecture today. Is it built to scale or is it built to stall? Thanks for joining me on this explainer, and happy architecting.